Well, we've got a very special speaker up next. I'm excited to introduce Ladar Levison. He is the founder of LavaBit, which was really big in the news just last year at Inbox Love. And just before that, all around the Edward Snowden revelations around NSA snooping and what's happening to our email. And as much as I do understand how difficult of a situation this is for large companies like Google and Microsoft and Apple and others who are forced under these gag orders to cooperate with the NSA and to in one way or another and expose different things. Ladar, running his little mail server, was really one of the only people that stood up and said, no, this isn't okay, and I'm not going to hand over the keys, and I'm not going to expose all my users' email to you. At one point, I think he printed out the encryption keys in binary in like these big stacks of paper for them. Really, and it stood up for himself and I think for all of us. And so I really appreciate the things that he's done and the risks that he's taken personally and professionally for himself to make that happen. And so last year, Ladar announced DarkMail, which is a new initiative to help provide end-to-end encryption and security for everybody and try to make it easier to use and accessible. And we're really lucky to have him back here with us today to give an update on what's been happening with DarkMail and kind of the future of our email privacy. So I think we're wiring him up right now.
Yeah, the running through the shirt didn't work. Not used to getting dressed under pressure.
No problem. All right, well, I'm going to hand it off to Ladar. Thanks, Ladar.
All right, thank you. That was a great introduction. My name is Ladar Levison. I am passionate about information security, and I care a lot about protecting email privacy. It's something I've been focused on for the last 10 years. So Josh asked me to come and talk about the changes we've seen in the email security space in the last year. A year ago, we were very good at protecting the connection between the desktop and the server. We've been doing it for years. Started back in the late 90s when we wanted a way to protect our credit card numbers as it traversed the network. That technology got pushed down to email. And as you can see, close to 90% of the people accessing my server a year ago via IMAP or POP were using SSL. SMTP, on the other hand, was lagging behind. What you see there is the penetration rate of about 10%, which roughly equals the ratio of outbound to inbound messages that my server was encountering. So I'm guessing most of those 31 secure connections were actually message submissions by users who were using SSL and not server-to-server SMTP over TLS. That has changed. A survey done in May by a large social network found that close to 76% of the MX records they communicated with in a one-week period supported Start TLS. And that almost all of the servers that supported TLS also offered a cipher suite which provided for perfect forward secrecy. But there was a problem. Only about half of those servers actually presented certificates that would pass strict validation. In layman's terms, that means that the certificates that were being presented, if presented in a web browser, would have caused a big red flag and given the do not proceed error message that we all are used to seeing. But it's been getting better. As of just a few weeks ago, almost all of the TLS certificates that they saw would pass validation. And thanks to Microsoft enabling Start TLS for their mail clusters, this summer, we now have close to 90% of the mail servers on the internet support TLS. That's a big improvement. It means that somebody listening in on the network can no longer sniff up your email. But unfortunately, there's a problem. There's no way to tell MTAs that are connecting to your systems that you actually support TLS and that you should use it. What that means is that if somebody sits in the middle, they can intercept your connection, remove that extension from the hello response, and prevent that message from going over TLS, and there isn't anything we can do about it. We simply don't have the protocols in place to support that kind of security. If you're a machine that's using a self-signed certificate, for example, they wouldn't even need to do this. They could replace it with their own certificate and associated key, and nobody would be able to tell the difference. Now, the CA system has some problems, and the only tool we have right now to fight it is this little guy that most of you have probably never heard of. But it's a way of sticking the fingerprint for your TLS certificates in the DNS system. Of course, it has one big barrier to adoption besides nobody supporting it. It requires DNSSEC. I guess I'll divert for just a second here and say that DNSSEC, a year ago, saw less than 1% penetration. Today, we're up closer to 10%, which is a big improvement. If you don't have DNSSEC deployed for your domain, it means that anybody can sit between your DNS servers, the outside world, and redirect people trying to access your systems to another IP address. Now, there's another problem with email. And before I get to that, I'll talk about a very recent corollary that some of you may have heard of. What somebody realized is that it's now possible to see a binary attachment going across the network, or in this case, a file being downloaded using Tor, recognize that file, and inject malware into the executable in real time. Now, if you've thought ahead, you'll realize that the same thing could be done to an email message. If you're able to prevent the connection from using TLS, you see the message in the clear, you see that somebody, presumably a recognized sender, is sending a message with an attachment, whether it be a Word document, a PowerPoint, a zip file, an executable, an MSI, an XPI, an APK. You can inject malware directly into that file, and when the unwitting recipient receives it, they install it thinking they're installing something from a friend, when in reality they're getting some undocumented features in addition. It's a big problem. What's the solution? End-to-end security. Complete message encryption. We've had it for a while, since the early 90s with PGP, and later with SMIME. Both have received very poor penetration in the market. If you've ever tried to use it, you'll understand why. You practically have to have a PhD in cryptography and mathematics in order to know how to use those tools, or at least understand them. The best you can hope for is to have somebody who does know how to use them show you the way. But even as difficult as they are to use, there's been a huge jump in their usage in the last year. Now, briefly, SMIME is supported in just about every major MUA out there. It seems to be gaining momentum inside the corporate space, or at least it was until about 6 months ago. But next to nobody uses it one-on-one in their personal accounts. And even its corporate deployments haven't been that thorough. But it does have some advantages. Tends to work a little bit better, does a slightly better job of structuring the messages so that they're compatible with various implementations. PGP, on the other hand, has seen a huge, albeit massive uptake. I've heard some people say they're seeing almost 10 times as many PGP encrypted messages traversing their network today versus a little over a year ago. It prevents a lot of the problems that I just mentioned. You can't inject malware into an email message if you can't figure out what's in the email message in the first place. You can't impersonate a trusted sender if you don't control their private key and can't sign the message as them.
Can I interject a little question here about the difference between encryption and signing here? Because you seem to be conflating the two a lot. Encryption doesn't protect it, signatures do. And regardless of whether it's actually
Encryption provides for message confidentiality.
yeah.
It ensures that the content of the message is secure. Signing is the process of adding a signature, like your John Hancock, to the end of that message, which allows a recipient to cryptographically verify that you were the actual person to send it.
Yeah, but signing is what will stop you getting a piece of malware. Otherwise, you just get something else encrypted to your public key, which is still malware.
True, that is, signing would prevent you from being able to modify that message in transit, but it wouldn't prevent you from being able to strip off that signature altogether,
Yeah.
which does happen. I use PGP quite a lot, and I occasionally get messages encrypted to me from somebody who regularly signs their messages, but didn't for whatever reason on that particular occasion. What we have seen in the last year is a growing trend to improve the accessibility and usability of the tools that are out there, particularly PGP. And we're going to hear from Stefan next, who's going to talk about Google's effort to do that. But we still have some hurdles to overcome. The tools we have out there don't protect metadata, which, as we've realized in the last year, is becoming an increasingly important commodity. And there's still a lot of interoperability problems. The problem with the PGP standard is that, having been around for 20 years and only standardized after it was in its teenage years, means that not all of the PGP implementations and methods for using it out there are compatible with each other. Where do I think we're going in the future? I think we're not far from a world in which the mail infrastructure becomes a commodity which moves around faceless, arbitrary containers we call messages without being able to peek inside. If I were to use an analogy, it would be that of a cargo ship. The captain of the cargo ship doesn't always know what's inside those containers. He just knows where he has to pick them up and drop them off. So think about how that's going to affect your applications. It means more of the logic is going to have to be pushed down into the mail client itself.
Seems to be the opposite of the trend.
It is. For the last 20 years, we've been doing everything on the server because we could. We may not be able to count on that type of functionality forever. Now, the good news is that even with a webmail system, we're getting pretty adept at writing JavaScript applications like the presenter before me demonstrated. Those are on the client. Those are on the device. Those can operate on the message after it's been decrypted.
And do whatever they like with it.
That's, yeah. I figured I'd end with that problem, but what I've been working on is a solution called the Dark Internet Mail Environment, which takes the best properties of SMIME and the best properties of PGP, adds some special sauce, mixes it together, and hopefully will create a system that allows us to achieve end-to-end security automatically for the user, so they don't have to know about the differences between elliptical curves or key sizes, or even deal with the process of looking up somebody's key and trying to determine if it's the correct key for that person. If PGP is a cargo container Dime is a little bit more like a battleship. The prevailing perception in the security community right now isn't just that you have to worry about the server on the other end sending you something malicious. It's the idea that the entire network itself might be hostile. I would liken it to the Wild West, where we're all wandering around with a six-shooter on our side trying to defend ourselves. And some of us are better at it than others. What was just mentioned a moment ago is one of the big problems we have in security as more stuff moves towards the web. You can store the private encryption key in encrypted form, say using a passphrase on the server. But if you load the code to decrypt that key from the same place you load the key, there's nothing stopping an attacker from gaining control of that server, legally or illegally, injecting something into that JavaScript code that sends the key back to the server after it's been decrypted. It's actually a problem that the internet standards bodies and the security working groups are well aware of, and there is no easy solution to it. The only answer we've come up with so far is to use things like browser plugins. If you're familiar with an HSM, a browser plugin could be thought of as a VSM. It insulates the encryption code from the code being loaded from the untrusted server. It's not a perfect solution. It could still be used to decrypt a message that an attacker wanted, but it may not be able to steal the key outright. Like I said, I'm not smart enough to come up with a solution to that one, at least right now. So that's where we're at. Got about 4 minutes left if anybody has any questions.
When do we get DarkMail?
Excellent question. I would have thought a year ago it would have been done by now. But I tend to be overambitious. Right now, we're looking at releasing some draft specifications at the Chaos Communications Congress at the end of the year, and hopefully some working library components to deal with the various formats and protocols. In a perfect world, I'd say by then we also have them integrated into the server and client, but that's looking less likely.
So security is three things, right? It's availability, it's integrity, and then it's protection against someone else reading it. They're kind of the three phases of security, and you're very much focusing on the stopping other people reading it. A lot of people also care about being able to access their email, obviously, and knowing that it hasn't been changed, which is a different problem again from knowing that nobody can read it. If you push all the encryption out to the client, particularly something like mobile, it says
not possible to a mobile device
to be able to search the history of your email by fetching every single message and reading it. How do you deal with that side of things?
So,
just for the recording, and the question at the end of it all was, if you push everything down to the client, how do you deal with something like searching all your archives, which is probably pretty hard to do on your client?
yeah, encrypted search is actually a big problem. The best solution I've come up with so far is to build the search index in the client itself when it reads the message for the first time, and then push the encrypted search index back to the server. It's a future goal for a possible DIME extension, because I'm not smart enough to design a protocol that synchronizes an encrypted index on a server based on what it reads from a message. But one of the things that I have done with the DIME message format is optimize it so that a message could be split apart securely and pushed out to a resource-constrained environment like a mobile phone. Because that's one of the many problems that we have with the end-to-end encryption technologies today. If somebody sends you a one-line message with a 30-megabyte attachment, your phone quite likely will have to download that entire 36-megabyte message, because it has to be base 64 encoded, before it can show you that one line. It's a problem that I've tried to address with DIME.
interestingly enough, also to invoke Gabor again. 4 years ago at the first Inbox Love, I think he had just come out or had Remail out, and that was an iPhone app which did actually download a secure encrypted index of all your messages to your phone and was able to do it pretty efficiently, where it was keeping it locally and making it searchable, and maybe some combination of pushing it back up to the server or something like that could be pretty cool. I'm pretty sure that got open sourced after Google bought it.
So what I've thought about doing is having the client maintain a search index locally. The problem is, how do you push the portion that gets updated back to the server without having to push the entire index? And if you've got 100,000 messages in your mail store and your index is 150 megabytes, a 300 byte change results in a 150 megabyte upload to the server over a limited connection. And that's a problem. I saw a couple of hands way over there.
Yeah, so like in the transition period from existing email to the next generation, are you designing it in such a way that regardless of who you're sending to, you could send one of your formatted messages to anybody? What? All right, so my question is, like, during the transition from existing email to a new email paradigm, are you looking to implement the protocol in a way where you can send, if you've taken the step to create a new email address or adopt this new protocol, that you can send to people with all the protections that you want to people who have not adopted the system yet, or on ISPs that haven't?
So the question is, what happens when you want to send a message? You're on a DIME-enabled domain using a DIME-enabled client, and you want to send a message to somebody who's using one of the legacy mail protocols, sending what I like to refer to as naked messages. The way it works now is the client actually recognizes when you type in an insecure email address and warns you by changing the UI to a bright red color to indicate that that message is going to go out over the network insecurely. So it's self-evangelizing in that respect. You know when you're sending a message to insecurely versus securely. The other thing to keep in mind that there's nothing about our protocol that prevents you from using something like PGP. One of the things that could be done is you could add your PGP key to your signet, which is our version of certificates, as an undefined field. Their PGP client could look up that signet, possibly not support DarkMail, but see that there's this undefined field called PGP key, and use that to retrieve the key securely. The problem, they could even use the DarkMail format to send the message using the encryption keys that are provided in that signet. The problem is the reply. How do you get that person's key if their domain does not publish keys for those users? Now, I don't have time to give a full overview of DarkMail, but one of the concepts that we're introducing are 3 different modes of operation: trustful, cautious, and paranoid. Cautious and paranoid do all of the encryption on the user's device. Trustful is a methodology where the encryption happens on the server and the organization relies on TLS to protect the information between the server and the client. So what we could see are organizations that don't necessarily want to switch to an MUA that supports DarkMail because they've got a lot invested, for example, in their Outlook applications, but they upgrade their servers, and all of a sudden, possibly via a proxy or because their MTA has added support for DIME, they're still able to communicate with other secure users, have those messages go out encrypted over the internet, and possibly have that encryption go all the way to the end user's device at the other end. All right, thank you.
Thank you so much, Ladar.